Hello, folks. This is Carl Freund again with Cambrian-AI Research, and got a pretty interesting topic to chat about today. There's been some major news this week from Intel and others. It's interesting because they are announcements of folks that typically would be considered competitors to Intel. And I think that's the big news here, is that Intel is partnering with what would be chip competitors, will be chip competitors, in order to collaborate on Foundry Services. So with us today, we have Dave Ditzel. Dave is the founder, amongst many other things. He's founder of Esperanto Technologies and executive chairman. We've also got Bob Brennan. Bob is the vice president at Intel Foundry Services. He's responsible for customer solution engineering there. So welcome, gentlemen. Thank you on short notice for making yourselves available.
Delighted to be here.
Glad to be here. Thank you, Carl.
Well, I'm really glad you guys are here. As you know from my blog, I think this is not only very interesting, I think this announcement is profound and will have impact on the industry for the next decade. Bob, if you wouldn't mind, let's just start, just brief the audience very quickly. Most people are very familiar with this, but from your perspective at Intel, brief them on what was announced and why you believe it's important.
Yeah, first of all, Carl, I want to thank you for your blog and your piece yesterday. I thought it was brilliant. And I think everybody watching this should go and read it immediately. What we announced yesterday was a $1 billion fund through Intel Foundry Services. It's an innovation fund to support early stage startups and established companies building disruptive technologies with the intent of building the Foundry ecosystem. In addition, we supported in that announcement a multi-ISA strategy where we support all computer architectures, x86, ARM, Risc-V. And regarding Risc-V, we announced that we are embracing Risc-V, the Risc-V open architecture, and the Risc-V open source software ecosystem. And lastly, we announced that we're investing and embracing in an open chiplet architecture to accelerate the growth of businesses adjacent to x86.
Boom. I mean, I try not to get too excited on this, but I think this is just massive shift, and it demonstrates Pat Gelsinger's intentions with the company. Dave, why don't you try to talk about not only what Esperanto gets out of this deal, but maybe broaden it a little bit in terms of what the industry impact will be for you and your competitors and collaborators as you seek access to Foundry Services and wafer starts.
Well, it's a big sea change for the industry. First, to add another massive fab capacity like Intel will have is a big deal. It's a way for startups to get access to leading edge technology nodes. But in particular, it's more than just silicon. Really, it's access to packaging technologies, which can put things together. It's Intel's help in establishing the software ecosystem, which is going to help propel the whole Risc-V ecosystem further into the future. For Esperanto, we're doing some very unique things. We're one of the first companies to put over 1,000 full 64-bit processors on a single die. And with Intel's technology, we're going to be able to move that in the future to where that current die, which is a pretty medium-sized die, will become a very small die known as a chiplet. And we can put that together, several chiplets together, along with chiplets designed by other companies. And that will help us design new products in a matter of months, simply by using Intel's packaging services with chiplets, as opposed to a matter of years when absolutely everything had to be designed by us or another single company and then taped out and get fully debugged with all the services. Chiplets enable you to put together already existing known working parts just with a simple assembly, and Intel is helping with a number of the standards that are needed for interfacing these chiplets to each other.
Well, I know when I was at AMD, we were working on something called the big APU, and the idea was to put x86 cores next to very fast data center GPUs, but we didn't have access to this kind of technology. And so we by necessity had to do this on an SoC. But this is really all about system on a package, right, Bob?
Yeah, that's exactly right. And Dave said it really, really well. Sometimes these have been called tiles, and sometimes they've been called chiplets. And it should be noted that Intel's been working on these chiplets for many years. We've had advanced package technologies such as Foveros and EMIB for our internal products for many years. The significance of this announcement is that we're opening up that technology to our customers into the ecosystem. And we're going to try and make it easy for our customers to build x86 adjacent solutions. And we intend to do that with an open architecture. And the open architecture will be comprised of CXL, Compute Express Link, which we previously announced, and a new die-to-die physical layer, which will connect our products to the sea of chiplets that we hope to develop in the future. So in sum, the combination of the package technology, this open CPU to device architecture called CXL, combined with a physical layer, an open SoC architecture, which is a SoC based on industry standards. We hope that will ease, enable, and accelerate the growth of adjacent silicon to x86 architecture.
Wow. Wow. I mean, and play it back to you, make sure we get it right. Basically, what was an Intel differentiator for your chip business is now becoming a differentiator for your foundry business as an open platform.
Excellent summary, Carl. I wish I had had you to prepare me for this interview.
You don't need my help. You absolutely do not need my help. So, if the magnitude of this shift, I think, will take time to materialize, right? I mean, Dave, I'm guessing you probably weren't planning to tape out your next platform on Intel. Now that's certainly an option for you, and was not really a viable option, or at least one I doubt you were considering. Talk a little bit about what that means to Esperanto.
Really is a different feel for the business. Before, Intel was just so dominant, and they were the dominant competitor, and we had to compete against them in a market where we build accelerators to plug it into a PCIe card. So in some sense, 90% of the time we'd be in a system that plugged alongside an Intel CPU as well. And so how do you deal with that when you're directly competing? Intel has just transformed itself with this announcement into somebody that can be our partner instead of only our competitor. Now, what this means is we get to build on top of Intel's innovation. For the kind of computer systems where you accelerate AI, you still want an x86 CPU to run the operating system, to interface with all the heavy peripherals, everything else. And then that's something that's way beyond the capability of most startups to go and design their own CPU of that level to be compatible with x86. And I know I've done that before, not something I wanted to do again. So what this lets us do then is to align with Intel, possibly even use, as Bob called it, Xeon adjacent chips, okay, on the same physical package to talk to us. We get this at an extra high speed of being on that same package, right? And then we can put our innovation on top of whatever innovation Intel had, right? So Intel is free to innovate, do their best, but they get to take advantage of all the startups and other companies out here who might have some other clever idea and put that together. So I think it's really going to increase the acceleration of new ideas getting to market, and chiplets is just another way of actually making that happen even faster, because then we can assemble these pre-assembled parts, and just with some simple using Intel's advanced packaging, put these things together in a matter of months to provide a different configuration for a customer who says, oh, I like your product, but really I need twice as many CPUs as you had before. Can you do that, right? Well, now by using chiplets, we just put down 2 chiplets in a package, and suddenly we've got a new product.
Wow, it's kind of like we're enabling the industry to innovate with each other and combine innovations and build on top of those innovations to accelerate new products and
Well,
technologies.
it's compounded growth, right? Rather than
Yeah, compounded growth.
isolated, innovation that has to compete against each other. So
Yeah.
I think we're looking forward to everybody at Esperanto working together with Intel to see what can we do to use the best of their technology along with our ideas to do better products than we could have done in just a pure foundry relationship.
So, let's turn our attention for a moment to Risc-V. Risc-V came along and it was interesting technology, first at universities and researchers, and then became a platform for embedded microprocessors that did not have the, let's just say, economic burden of a licensed IP from ARM. But now, I would imagine the $1 billion that Intel is making available to help accelerate this multi-ISA architecture has got to have a material impact on the future of Risc-V, especially as we talk about the entrance of Risc-V in the data center. Dave, can you elaborate a little bit on that?
I think there's three critical points that I think your listeners will need to distinguish between. One is chips, and we talk about Risc-V, but really Risc-V is more about the instruction set that is in common between the chips. And then there's software. So what we've learned is, every year or two, there's another chip that comes along. But as we often say, software is forever. Software will last 10 or 20 years, right? And this is something where this is an investment with Risc-V that'll go for the next 50 years. The hardware will continually change. But we need to build that software ecosystem up, right? Intel has done a fabulous job, and this is why x86 won over the years, was they helped build up that particular ecosystem here. Risc-V is coming up in parallel. Doesn't mean the other will go away, but this will enable different kinds of products. And to have Intel investing in that ecosystem to make it happen even faster is really important here. And so, again, the Risc-V instruction set is something that everybody can use in common, so that we can use common software, which drives all of our products. But Risc-V also allows the freedom to innovate and add things on top. So in this particular case, Esperanto has added specialized enhancements to the Risc-V instruction set for artificial intelligence that allow us to do that better and to allow our particular Risc-V implementations, let's say kind of the chips that we put together, to work together in parallel to make 1,000 different processors behave in a more efficient way than an individual processor might do. So putting those three things together here really is, I think, going to accelerate the entire industry. And we can work on a common software base that we can share into the future. And customers like it because if one chip supplier can't provide exactly what they want in the future, they can find another Risc-V supplier and feel like they won't be losing that decade of software investment they might have put in, which uses Risc-V as the base instruction set.
Well, that's really, really profound, because my view is there's going to be a lot of companies that have really great hardware for running innovative AI models, especially new, larger models. And I'm not saying that's easy, but compared to the software challenges those companies face, the hardware is the easy part, because the software has to be embraced by so many people outside of that company's control. And Bob, I would think that your innovation fund will be a catalyst for spurring that kind of software adoption and co-development in an open environment, an open industry.
Absolutely. And so I'd love to talk about Risc-V for a minute if I could.
Please.
So, Intel going big on Risc-V is, I think, a significant announcement. As you might have seen yesterday, we joined Risc-V International, and we hope to make contributions to the open architecture. As Risc-V International was already working on, we hope to standardize profiles such that the ISA is stable for software development, and that will be critical. We've also announced yesterday partnerships with Dave's company, Esperanto, as well as Andy's Sci-5 and Ventana systems, and that we're going to optimize their products on our semiconductor process and our package to offer their IP to our customers. We also feel as though, as Dave mentioned, that we need to really work on the Risc-V software ecosystem. Intel has a long history in open source. If you look at our history, we started working on open source Linux about 20 years ago. We plan to apply the same playbook here, where we invest resources in creating an open source software ecosystem, and that will enable the growth of silicon on IFS. And specifically with one of our partners, Sci5, that's the initial one, for which we will develop a reference board, and we will offer that to developers to start working on their software. I'm sure Dave will get ours done soon, sir. But the idea is that we need to create this virtuous spiral that x86 enjoyed for the last 3 decades of open hardware reference designs, open source software, and that will create a spiral. And we feel as though that will accelerate the adoption. So we feel as though that will create the demand pull. And then, of course, $1 billion is a nice catalyst to accelerate the ecosystem moving in that direction. Of course, naturally, we hope that that creates a preference for IFS solutions for our customers.
Interesting. Yeah, the timing of this is very interesting. I don't want to use the word ideal, but it is close to it, with ARM now probably heading towards an IPO, remaining independent, coupled with the emergence of Risc-V platforms that are competitive in terms of per core performance, and innovative. If you look at what Dave's team has done to extend that ISA into an implementation into new market areas, you combine that with the current supply constraints, especially for advanced node, right? I mean, especially for advanced node. So, and then finally, add to that the fabrication facilities that Intel is investing in and breaking ground on and building up to bring more supply capacity online. I got to think that 10 years from now, we're going to look back on this as a seminal event.
Yeah, I was super impressed to see Pat Gelsinger on stage with the President of the United States announcing our $20 billion investment in Ohio. I just thought, I was tickled. I watched that video twice and I just thought it was great. You know, Carl, the demand for semiconductors is unparalleled in my lifetime. It really is pervasive in everything that we do. And we see that demand continuing to go up, both for our own products and for our customers' products. And there's only a few companies in the world that we think that can build the capacity that we need to support our customers. And we're pleased to do it. Now, by the way, one more thing I wanted to mention about ARM. We love all our silicon. So I just wanted to be clear that yesterday we did announce a partnership with ARM through our IP Alliance, or our IP Accelerator, whereby we're optimizing their technology with what we call DTCO and STCO, Design and System Technology Co-optimization. So, you know, I don't want your viewers to take away that, you know, we're all in on Risc-V and nothing else. We love all our silicon.
I love
you
that.
can let the best technology win. Whoever it is, you can fab it.
Right.
Right. I mean, if you have competitive fab services and process node technology and additional IP that you can offer to make yourself seem very attractive as an option to these ISAs, implementation partners for all of these ISAs. It's just a totally different world. Any last comments, Dave, that you'd like to close with?
One is, I think, you know, the world really is changing, and this is going to enable a lot of new products. In the past, we kind of thought of computers as something with a keyboard and a screen, right? And, you know, they ran a particular operating system or something, and that was a very nice software base. But in the future, I think we're only barely beginning to see the start of the influence of artificial intelligence, where you can just speak to a device. If you think of how much voice recognition has improved in the last 10 years, right? You can talk to computers now and they will understand very complex speech. And this will be turned to where every device you talk to, from lamps to devices in your home, everything will have a smart interface. And I think that is what's going to create the insatiable demand for lots of different kinds of computing. It'll need lots of kinds of innovation. So I really want to thank Intel for their innovation fund. I think it's going to encourage lots of different kinds of devices that we can only barely imagine today. And this is going to cause an explosion of silicon demand. And really, we need the extra capacity Intel is bringing on from a foundry basis, because as we can see right now, a lot of the other suppliers are just sold out for the next several years. So, I think this is really a pretty momentous occasion. Embracing Risc-V is going to be a pretty big deal. There have been attempts at other open instruction sets in the past. We tried to make the Spark instruction set open and so on, but it never got critical mass. And so I think Intel's endorsement here is the thing that's going to propel everybody, above this critical mass stage to let us get a software ecosystem that really will let this go forward. And I think you can just see an explosion of all kinds of interesting, different silicon devices in the future.
An exciting future indeed. Bob, any final comments?
I guess I want to leave you with the word open. We're open to any core architecture. We are embracing an open Risc-V architecture. We're embracing open source software. And we're creating and embracing an open chiplet architecture. Plus, we're accelerating our customer time to market with $1 billion innovation fund. So I'd leave you with a phrase, we're here at Intel Foundry Services. We're here to help you, and we are open and open for business.
Well, there's been a lot of assertions by Intel in the past of being open, and it failed to materialize, in my opinion. I think this time around is going to be different. You're talking about a lot of money, and you're open to all ICEs and open to all customers who are frankly getting frustrated by not being able to do advanced process wafer starts in the major non-Intel foundries. So this is going to open up the aperture quite a bit, and I wish you both success. Thank you so much for jumping on the phone with me and sharing your vision for the future with my audience. Thanks again.
Carl, thank you very much.
Much.
Take care, guys.
Your time.
Stay well.
Thank you.
Stay well.
Okay. Bye-bye.